All right, so yesterday we started law of sines, section 4.2. We'll continue it today looking just at that special case where you get the two solution, one solution, or no solution. Okay, just as a reminder, that's what the law of sines is. To generalize it, you can just remember that it's sine of an angle divided by what's across from it. Equals sine of another angle divided by the side across from it. So even if they don't use A, B, and C, you can remember sine of an angle divided by the side that's across from it. All right, there's nothing new to really explain. We already went through part of the proof of how you get this, so let's just jump into an example. All right, so in this example, A is 6, B is 8, alpha is 35. Okay, one way that I know this is the side-side angle case, without even making a diagram, if you look at the table and you have a row with everything in it. Well, first of all, if you got a row with everything in it, that tells you it's law of sines. What tells me it's the case that I don't like dealing with is I have a row that's completely empty. All right? So if you got a row that has everything in it and a row that's completely empty with no way of finding anything in that row, this is the case that could have 0, 1, or 2 solutions. If it's confusing to look at the table and figure it out, draw the diagram. A is 6, alpha is 35, B is 8, that's beta, C, gamma. Side, side, angle. And notice the angle that you know is not the one that's between the two sides. That would be gamma. That's a different kind of problem. Side, side angle. All right, what do I have to find first? Well, Chris, what out of the three things up there, what do I have to find first?
Beta.
Yeah, I've got to get beta first. Ignore this last row. It's empty. Cannot do anything with it right now. So set up our law of sines. Okay, and Chelsea, what could I put on the left-hand side? Let's use a row that we have all the information for.
Sine 35 over 6.
Good. Sine 35 over 6. Okay, now as Chris just said, we've got to find beta, so use the second row. Sine of an angle, divide by what's across from it. Okay, we'll cross multiply. Okay, so far there's nothing new. Okay, this is all the stuff we did yesterday. 6 sine beta equals 8 sine 35. Move the 6 to the other side by dividing by it. And now I've got sine beta equals 8 sine 35 over 6. Katie, what can I do so I just get beta and get rid of sine?
Inverse sine.
Yeah, we'll squeeze it in right here. Take the inverse sine of what's on the left. Inverse sine of what's on the right. On the left, inverse sine and regular sine cancel. And we have a formula for beta. It's the inverse sine, 8 sine 35 over 6. Now, in the past, people have looked at that and noticed that 8's divisible by 2, 6 is divisible by 2. You could reduce it, but you're just going to type it all into the calculator, so I wouldn't bother. Okay, if you reduce it and make a mistake, then you've messed up the problem. So just leave it. So once we type that in, we're about to find out if this problem is at least a no solution or it's going to have solutions. If it has solutions, we won't know how many yet. We've got to go through that process to check. Okay, so inverse sine, 8 sine 35 over 6. Okay, this is not a no solution problem. I have at least one answer. Okay, 49.886. Write it up in the box a little higher. That way, if there's a second answer, we'll just put it right below it. If there isn't a second answer, then we won't put anything below it. Okay, Charles, what do I do with that number that I just got to get my second answer?
So you track it from 180.
Yeah, so I'm going to do 180 minus 49.886, and I get 130.114. Okay. Not saying that is the second answer. We have to check and see if it would fit in the triangle. Okay, so JC, what angle were we given to start?
35.
We were given 35. Is it possible to fit something that's 130 and a 35 in the same triangle?
Yes.
Yes. If you add up 130.114 and 35, it only adds up to 165. That's below 180. So the second answer does work. So we're going to write it down. We'll call the first answer beta 1, our first beta. And then we'll have beta 2. Well, if there's two answers for beta, what else do you think that means?
2 answers for gamma.
Yeah, there's two answers for gamma. And if there's two answers for gamma, there's two answers for C. So what we're doing now is we're solving two separate problems. We're using the same table to organize our data. But if you were to draw these out, you have two different triangles. They have some sides and an angle in common, but we're doing two separate problems. Okay. Let me put a red box around everything that's one triangle. Okay. This side, and that side. Those are the three sides in one triangle. And here are the three angles that go with them. This, that, and that. So everything in the red box, that's one triangle. Okay, everything in the blue box, this will be the other triangle. This side, and that side. And the angles that go with them, that one, and that one. So notice A, B, and alpha, they're in both triangles. Those are the three things that they share. Okay? All the little numbers, all the ones, beta 1, gamma 1, C1, that's a triangle. And then the beta 2, the gamma 2, and the C2, that's a different triangle. Okay, so if you look up there, there should be 6 things in red, 3 sides and 3 angles, and 6 things in blue, 3 sides and 3 angles. 2 separate triangles. Okay. Any questions so far on how we got beta 1 or beta 2 or how we figured out beta 2 works? Okay. Next we're going to find gamma 1 and gamma 2. We just have to use the idea that all the angles add up to 180. What two angles would I add together and then subtract from 180 to get gamma 1? Jordan?
The 49.886 and
Yep.
35.
Right. If you take 180, subtract 35, then subtract 49.886. Leaves you with 95.114. That's gamma 1. Okay, now we're going to find gamma 2. Anyone think they know what two angles I would use to get gamma 2? Oh, Rosa?
Would use the 130 and the 35?
Yep. Everything in blue for those angles. That's another triangle. So we got 35. So we'll subtract that. We have 130.114. And that leaves me with 14.886. Okay, this isn't really harder. It's just you're doing everything twice. It's longer. But it's not more advanced math. You're just doubling the amount of work in terms of time. Okay. All right. Now we have to get C1 and C2. Which row in that table do you think we're going to use It's going to be a very important row. We're going to use it to find C1 and C2. We're going to use row A. Because it was given, it's in both triangles. Side A is in both, and alpha is in both. So we're going to use that row. Okay, so let's start with that. Sine 35 over 6. Now, let's start with C1. Which angle do you think we'll use to find C1?
95.114.
The 95.114. Okay. Gamma 1. To find C1, use gamma 1. To find C2, you use gamma 2. So let's set it up for C1. Sine 95.114 over C1. Let's set up the other one while we're going. We're going to use row A again. So sine 35 over 6. This time, use gamma 2 with C2. Sine 14.886 divide by C2. Okay. Questions on how I set that up or why I set it up the way I did? Any question? Jen, do you have a question? No? Okay. Any questions?
Should we have a question?
No, I don't think so. Some people are just looking maybe a little confused, so I wasn't sure. Seems okay? All right. Now we just solve each one of them. Just cross multiply. So C1 is going to be 6 sine 95, 114. Oops, 114. Divide by sine 35. Okay, I'll leave plugging that in to your calculator for you. And then C2. Okay, anyone think they can tell me what C2 is going to be? You don't have to give me the decimal, just the what times what divided by what. Yeah.
It'd be 6 and 35 divided by, no, sorry, 6 and 14.886 divided by 6.
Yeah, so it's the 6 times the sine of 14.886. That goes in the top, and then the sine 35 goes in the bottom. Good. And again, everything this week is degrees. Okay, any question on that? So that's the worst kind of problem you can have. Doesn't get any harder than those. That's the 2 solution. Right, so we started off class with the 1 solution, okay, going over the homework problem. This is the 2 solution. Let's see what happens when we solve this one. Any guess what you think is going to happen?
No solution.
Let's see. Well, I know it's the case I don't like to deal with because I see a row that has everything in it. I see a row that has nothing in it, and I have no way of finding anything in that middle row. You can't, for those that weren't here, you cannot use Pythagorean theorem because we don't know if it's a right triangle, and most of the times it's not. So when I look at it, I'm forced to solve for something first. Okay, Zach, what do I have to find first? Yeah, I gotta get alpha. Okay? I have no other choice. So let's set it up and see what happens. So we have sine of 50 divided by 1 equals sine of alpha divided by 2. Okay, cross multiply. Because we have a 1, that's going to be nice. It's just 1 times sine alpha, just sine alpha. And then we have equals 2 sine 50. Okay, let's see what 2 sine 50 is. I just want to see what the decimal comes out to. There's the sine of 50. There it is times 2. It's 1.53. Okay, when we did that graphing last week, what was the highest and lowest that sine and cosine went? Without transforming it. -1 was the lowest, and 1 was the highest. This came out to 1.53. Basically, what I'm asking you is, if you were to draw the sine function between 1 and -1, where does it hit this number? 1.53.
It doesn't.
It doesn't. 1.53 would be somewhere up there. So I'm basically asking where that curve is going to hit that line. It's not. So let's see what happens if we try to finish this up by taking inverse sine of each side. Okay, we know something's not going to work. So take inverse sine of what's on the left. Do it on the right. And alpha, if it works, is going to be the inverse sine of 2 sine 50.
How'd you come up with 1.55?
I typed it in.
Oh,
I just typed it in what was on the right-hand side, just to see. That step's not necessary, but I'm just trying to get you in the direction of understanding visually why there's no answer, because you're trying to find where two things cross that don't cross. Can't do that. So let's see what happens when you type it in. Inverse sine of 2 sine 50. It says error. Okay. So what I do is go back, check, make sure, did I type it in right? Inverse sine 2 sine 50. Yep, typed it in right. So because I'm getting an error, there's no solution. Well, if you can't get a solution for alpha, you can't add alpha and gamma together and get beta. So then there's no solution for beta. And if you can't find beta, you can't find the side that's across from it. So there's no solution for this problem. Okay, and if we had time, what I'd do is I'd go through and sketch it. And if you try to sketch a triangle that's 2 units on one side, 1 unit on the other, and an angle of 50 for gamma, in the spots that I've written, you can't sketch it. It's a triangle where the sides don't meet. Okay? It's just a triangle where the sides do not meet. And that's it. That's the no solution case. There's nothing else we can do. Any question on that one? All right, our last one, I think we'll look at is a word problem. Okay, sometimes if I have a chance, I try to print it out so you don't have to write it down. With the MCAS, I didn't have a chance this morning. But it's also probably probably grab this problem from your book. Yeah, does it say find the height of a mountain 900 meters apart? Yeah, this is example 6 in the book. So if you want to look at it. Example 6. All right. So what's happening here is a surveyor is going to measure the height of a mountain. And the way they're going to do it is take 2 separate sightings. Okay, the sightings are going to be 900 meters apart. Okay, so basically what he's going to do is he's going to stand at a certain point. He's going to use probably a transit or something similar to measure the angle to the peak of the mountain. And he's going to back up 900 meters. And he's going to set up his transit again. He's going to look through it and measure the angle to the top of the mountain again. The only thing he has to keep track of is the angle that the transit measures the first time, the angle it measures the second time, and how far back he walked between the 2 times that they did it. Right, so the first time they set up the transit and look through it, the angle of elevation is 47 degrees. Okay, an angle of elevation is basically if this is your horizon, and here's an object, and you're looking from ground level up at that object, what would the angle be? Okay, then, as I said, the surveyor is going to back up 900 meters, set up the transit again, and measure another angle. Okay, as you back away from something, the angle starts to get smaller. Okay, so this time it's only 35 degrees. Okay, a good way to think of that imagine you're looking at like a big, like a movie screen. If you're right close to the movie screen, like first row, you're looking up, the angle's really steep. Right? You start to back up a little bit, you don't have to look up as steep. The angle starts to go down a little bit. Okay, same idea. To make it simple, we're going to assume that the transit is level with the ground. Okay, normally a transit might stand up about 5 feet and then they look through it. But just to simplify the problem, we're going to assume that the transit is on the ground. Okay, just makes it a little easier. Okay, so our goal is to find the height of the mountain. How do you find the mountain height? Well, first thing you want to do is try to set up a diagram. I've already kind of given you a hint, but in any kind of problem we're talking about a mountain, you probably have a mountain, be a good thing to have, and something to put it on. So draw flat ground. So there's our ground. There's our mountain. And remember, the surveyor is going to take 2 separate readings. The surveyor is never going to know how far they are from the mountain. They don't need to know that. Okay? They don't have to know I'm exactly 5 miles from the mountain, 10 miles from the mountain. You never have to know how far away you are from the mountain to get the height of it. All right. So let's mark the 2 spots that the surveyor does his measurement from. And what do we know about these 2 spots?
They're 900 meters apart.
It's 900 meters apart. Okay. And let's draw in an angle of elevation to the top of the mountain. What was our first angle? Yep, first one was 47. Okay, backs up 900 meters, does it again. Notice the angle gets a little smaller because they're further away. Now it's 35. Okay, our goal though, remember what we really want is that. We want the height of the mountain. Well, let's start by looking at this angle right here. I know this one to the right is 47. How could you get this one to the left of it? Yeah, together the 2 angles near this first x make a straight line. So subtract the 47 from 180. So the angle inside here is 133. Okay, let me sketch that triangle we have on the left. Looks like this. This side's 900, 35, 133. What kind of triangle is that? Using our 3 letters. That's an angle side angle. Okay. So using law of sines, we can solve that problem. Now, is any side in that triangle the height of the mountain?
No.
No. But if we could find how long that side is right there, that's this side right here. What kind of triangle do I have in red?
Right triangle.
I have a right triangle. And if I can find this side in red, the longest side in it, what the longest side is really the what? Yeah. This side right here, which is the same as that side right there, it's the hypotenuse. Okay, so if we can figure that out, then we have the hypotenuse. Then we can use right triangle trick to find the height of the mountain. So this is really like 2 steps. 1, we've got to find this length. And then 2, we can find the height of the mountain. Right, here's where it's important to just understand the idea of law of sines, because we don't have anything labeled A, B, C. So let's set it up. I've got 2 angles in the bottom, but I'm going to need this one at the top. The reason is I have to have an angle and what's across from it for this to work. So how would you get this angle up at the top?
Add the two angles and times it.
Yeah, just take 133 plus 35, you get 168. So the angle at the top is 12. Now I can set up my law of sines. It's going to be the sine of 12 divided by what side is across from the 12?
You typed in the wrong number.
No, it's just 35 on top. It just looks like 33 on the bottom.
35? It's a 35. Sorry. Sorry, so what side is across from the 12?
900.
The 900. Now, which angle am I going to use to find this side in red? The 35 or the 133? 35, that's across from it. Let's call the side in red, call it X. That's X. Okay, so X is going to be 900 sine 35 divided by sine 12. Okay, because we need that number, we got to type it in, round it off. Also, because it has to do with the height of a mountain, don't worry about being accurate to the nearest thousandth. Okay, we're going to round this answer probably to the nearest foot. How many feet tall is it? Or meters. Okay, sorry, meters. So there's the sine of 35 times 900 divided by the sine of 12. Right, so that side is 2,482.9. Close enough. Now, is that the height of the mountain?
No.
No. That's just this side. Okay. So what I like to do, let's draw that right triangle. Okay. Separate from the rest of the picture so we don't get confused. Okay. We just found the hypotenuse. It's 2,482.9. And we know one other thing.
47.
Yep, that angle inside is 47. Y, which I'll call it Y. Y is the height of the mountain. That's what I want, the height of that triangle in red. And now I have enough information to do it.
43.
Which trig function? All right, so what trig function could I use that would involve 2,482, the 47, and the Y?
Cosine?
Cosine would involve adjacent.
Pain.
Tangent still has adjacent.
It's a 50-50 chance.
Sine. So the sine of an angle equals opposite over hypotenuse. Maybe 2.9. And what would be my last step to get y by itself?
Times it by 2,482.
Yeah. Multiply each side by 2,482.9. Okay. I'll leave that step for you, but whatever that comes out to, that's the height of the mountain. Okay, so that was a tough problem because it involved a little bit of what we learned yesterday, along with right triangle trig, which we did a couple weeks ago. All right, so the homework tonight, again, not very many problems. Okay, I want you just to try 29 to 35 odd, 39 and 43. So six questions. Some of them will have no solution, so shouldn't take too long.